Okay, I wanted to do a really quick review here on heating curves. We talked about this the other day, but remember, heating curve is just a graph of temperature versus time. So you're going to have the temperature on the y-axis, time on the x-axis, that shows phase changes as a substance is heated. And the one thing that we talked about, one of the things that we talked about the other day, is that if the substance is being heated, it is an endothermic reaction. Let's see if we can get this to show up at least in the highlighter here. There we go. Okay, it's endothermic. So if we're going this way, it's endothermic. Heat is being absorbed, okay, or put into the system. Now, one thing we talked about is that the plateau between solid and liquid is much shorter than the plateau between going from a liquid to a gas, because the jump from a solid to a liquid is much smaller in the amount of energy than the jump between a liquid and a gas. Gases are 1/1000th as dense as liquids and solids, so that transition is going to take a lot more energy, so that's why that plateau is larger there. Now, what we should be able to do with these graphs is tell me a couple things. One, what phase is present at each part of the graph. So for example, this would be part A. This would only be a solid. Okay, as heat is added and the kinetic energy goes up and the temperature goes up, well, it's kind of bad there, but as the other things that will happen is that something will melt. Here is our melting point and our freezing point. Okay, so all the energy that's coming into the system on this plateau is going from taking those solid particles, giving them enough kinetic energy and enough heat to overcome the attractive forces just a little bit and enter that liquid phase where the particles can now slide past one another, but they're still close enough that they're not going to fly apart. As soon as all the materials transition to a liquid, we then are going, all the energy that's coming in is going to raise the temperature of that liquid, all the way up to the boiling point. Okay, once it hits the boiling point, it will actually stay the same temperature while it boils, while all of the liquid gains enough energy to become a gas. And again, here you have a big jump because the gas particles just have enough kinetic energy to overcome the attractive forces and to get that much further apart. And then once it's absorbed enough energy to turn everything into a gas, then the temperature can start to go up again. And then this last slide is just one last, it has what it has on here, all the phases. Okay, so things we should be able to identify are what phases are present at different parts of the graph, what phase changes are taking place, and recognizing the fact that as you go from left to right, the kinetic energy is going to increase and the temperature is increasing as well because it is endothermic. Okay, so again, it just labels your solid, your melting point, your freezing point, where the solid and the liquid are present, your liquid only, liquid and a gas, gas, and then the phase changes that are taking place. I hope that helps. Let me know if you have any questions.